We are told that wind energy is the future, clean, renewable, and infinite. We see the sleek white turbines spinning gracefully on the horizon, symbols of our commitment to saving the planet. But buried beneath this green revolution is a dark, mounting secret that the industry is desperate to solve but powerless to hide. When these massive giants die, they do not dissolve into the earth, and they cannot be melted down and reborn. Instead, they are trucked by the thousands to remote locations and buried in shallow graves, creating a permanent legacy of industrial waste. This is the mega defect of wind power. We engineered a machine to save the world, but we forgot to design a way for it to die. Today, we are exposing the three dirty secrets of the wind industry. 1. The thermoset chemical trap. 2. The landfill graveyards hiding in plain sight. And 3. The grand illusion of recycling. Let's dig into the green energy graveyard. Just as we often overlook the end-of-life reality of our physical technology, we often ignore the long-term security of our digital lives until it's too late. You wouldn't build a machine you couldn't turn off, so don't build a digital life you can't protect. That's why I use NordVPN. NordVPN encrypts your internet connection, ensuring that your data doesn't become digital waste floating around for hackers to exploit. Beyond security, NordVPN lets you access the global internet without borders, bypassing geo-restrictions to unlock content from anywhere. Secure your digital future today and use code DEFECT for up to 73% off, plus 3 extra months. Our first dirty secret lies in the fundamental chemistry of the blades themselves, the thermoset trap. To understand the waste crisis, you have to understand the engineering miracle that created it. A modern wind turbine blade is a marvel of aerodynamics and structural resilience. Some are over 100 meters long, longer than a football field, and must withstand hurricane-force winds, constant UV radiation, and millions of rotational cycles over a 25-year lifespan. To achieve this incredible strength-to-weight ratio, engineers use fiberglass-reinforced polymer composites. This involves taking layers of glass or carbon fibers and bonding them together with a liquid plastic resin. But here is the critical distinction. The resins used, typically epoxies or polyesters, are thermoset plastics. Unlike thermoplastics, think of a plastic water bottle or a Lego brick, which can be melted down, reshaped, and recycled endlessly. Thermoset plastics are cured through an irreversible chemical reaction. When they are heated during manufacturing, the polymer chains cross-link. Think of it like the difference between an ice cube and a cake. You can melt an ice cube and refreeze it. That's a thermoplastic. But once you bake a cake, you cannot unbake it. You cannot separate the eggs from the flour, and you cannot turn the cake back into batter. In a wind turbine blade, the glass fibers and the hardened resin become a single, fused, indestructible material. You cannot melt the resin to recover the glass because the resin will burn and char before it liquefies. We essentially engineered these blades for immortality, and we succeeded. They are so indestructible that even we cannot destroy them efficiently. This material defect means that every blade ever built is a permanent addition to the planet's massive synthetic waste, a one-way trip from the factory to the ground. So, what do we do with millions of tons of indestructible, unrecyclable cakes? We bury them. This brings us to secret number 2, the landfill reality. While the industry loves to talk about sustainability, the economic reality forces a much grimmer solution. In the United States, one of the most visible epicenters of this practice is the Casper Regional Landfill in Wyoming. This site has become a notorious final resting place for blades decommissioned from wind farms across the region. The disposal process is brutal, low-tech, and energy-intensive. These blades are so strong they cannot simply be crushed by normal landfill compactors. Instead, specialized crews must use heavy machinery and diamond wire saws to cut the blades into 3 massive, jagged sections right on the landfill site. This cutting process releases clouds of fiberglass dust, requiring workers to wear protective gear. These hollow curved sections are then trucked into massive open trenches and stacked. Because of their aerodynamic shape, they don't stack efficiently. They contain huge amounts of void space, eating up precious landfill volume at an alarming rate. The operators in Casper have been transparent about why they do this. It is currently the only economically viable option. Recycling a blade, if you can even find a facility capable of doing it, costs thousands of dollars per ton in processing and transportation. Burying it costs a fraction of that in tipping fees. It is a purely economic decision driven by the physics of the material. And while the industry argues that this waste is inert and non-toxic, the optics are devastating. We are literally digging holes in the earth to hide the waste products of the energy source that was supposed to save the earth. This brings us to the final, and perhaps most deceptive, secret: the recycling illusion. The wind industry is desperate to solve this PR nightmare, and they often tout recycling technologies in press releases. But we need to look closer at what that word really means in this context. The most common method being proposed and piloted is mechanical grinding. This involves taking the massive blade, shredding it into confetti, and using it as a filler material. It is often marketed as a feedstock for cement production or as a low-grade aggregate for road bases. This isn't true recycling, it is downcycling. You are taking a high-value, high-performance aerospace-grade composite and turning it into pavement or filler. You are not recovering the virgin materials to build new blades. You are just finding a slightly more useful place to dump the trash. The glass fibers lose their length and strength during the shredding process, rendering them useless for high-performance applications. Another touted solution is pyrolysis, baking the blades in an oxygen-free oven to burn off the resin and recover the glass or carbon fibers. While technically feasible, this process is incredibly energy-intensive. It requires massive amounts of heat, often generated by burning fossil fuels, to recycle a green energy product. Furthermore, the glass fiber that comes out of the oven, we are spending immense energy and money to turn gold back into lead, and the scale of the problem is accelerating. As we race toward net zero carbon targets, the installation rate of wind turbines is exponential. We are installing them faster than ever before, which means in 20 years, the waste stream will also be exponential. By 2050, industry estimates project the world will have accumulated over 43 million tons of blade waste. That is the equivalent weight of 215,000 locomotives, or 7 Great Pyramids of Giza, made entirely of unrecyclable plastic and glass. In the U.S., where landfill space is cheap, there is little regulatory pressure to stop the burials. We are prioritizing the deployment of clean energy over the life cycle of clean energy, solving the carbon crisis by creating a material waste crisis. The green energy graveyard is not an indictment of wind energy itself. Wind is essential for a sustainable future. It is, however, a damning indictment of linear design thinking. We design these machines for performance first, cost second, and disposal never. The mega defect was the arrogant assumption that we could figure out the waste problem later. Well, later has arrived in Casper, Wyoming. The industry is finally waking up, developing new resins that can be dissolved and recycled. But these technologies are in their infancy. For the millions of tons of blades already spinning above our heads, the grave is already dug. The legacy of the first generation of green energy will be buried in the ground, a fossil of our good intentions and our lack of foresight. What do you think should be done with these massive blades? Should we pay more for energy to fund expensive recycling, or is burial the necessary evil of a green transition? Let us know your thoughts in the comments below. If this investigation into the hidden cost of renewables opened your eyes, hit that like button, share this video, and make sure to subscribe to Mega DEFECT for more deep dives into the systems that fail us.